Welcome to Dr. Ken's Calculus. Okay, today's topic is formal definition of the limit, epsilon delta. Okay, let's see the definition first. Now, definition. Definition. Okay, for a function f defined on an open interval containing a point A. Then we say limit x approaches A, f of x approaches L. If for any epsilon there exists delta such that the distance between x and A is between 0 and delta, implies the distance between f of x and L less than epsilon. Okay, this is a definition, formal definition of the limit. We normally write like this. Okay, but formally it is written for any epsilon positive there exists delta such that distance between x and A is less than delta, implies the distance between the function value f of x and L is less than epsilon. Okay, let's see the graph. Okay, using graph we can see the picture. Okay, now this is a function, the graph of the function. This is A here. A. Okay, then it is here. Okay, so for any epsilon, we say for any epsilon, we are taking for any epsilon. Okay, the interval L minus epsilon to L plus epsilon. Okay, then we can find there exists delta. Delta is on the x-axis, the domain. Okay, that means the open interval A minus delta to A plus delta. Okay, such that so any point this delta interval, okay, the x is mapped into this epsilon interval. So although epsilon is very small, we can always find such delta. So inside delta interval, the points all goes to the such small epsilon interval. Okay, that's what the definition, formal definition says. All right. Okay, this is the formal definition of the limit. Okay, good. Now we just make it smaller so that we can do the example. Okay, good. Now we look at the example. Okay, example. Example. Okay. Prove limit x approaches to 3x plus 4 is 10. Okay, by that definition, the formal definition. Okay, let's prove this. So basically what we want to show, to prove, is that for any epsilon, any number epsilon, okay, there exists delta such that, okay, the distance between x and 2 is between 0 and delta, then it implies f of x, 3x plus 4 and 10 is less than epsilon. Okay, so what we do is that suppose that, okay, 3x plus 4 minus 10 is less than epsilon. So that means 3x minus 6, which is 3 times x minus 2 is less than epsilon. That means x minus 2 is less than epsilon over 3. Okay, now we compare the last inequality and this part here. Okay, almost the same. Huh? Okay, so if we take delta as equal epsilon over 3, then we can work backwards like this and reach the desired inequality. So therefore, okay, let delta equal epsilon over 3. Okay, let delta equal epsilon over 3. Then, okay, we can working backwards. Working backwards. This way, we can see that, okay, if the distance between x and 2 is less than delta, okay, then the 3x, distance between 3x plus 4 and 10 is less than epsilon. We can see this. Okay, so this is a proof. Okay, this is how we use the definition for the example problem. Okay, thank you very much. See you next time.